Now, what is the parent function of an exponential function? ETX. What's the general shape of this function? The first thing you need to realize is that it has a horizontal asymptote at y equals 0. So the graph is going to start from the x-axis. Now this function increases at an increasing rate. So it looks like this. The domain of this function is all real numbers. X can be anything. Now if we look at the y values, the lowest y value is 0, the highest is infinity, but it does not include the 0. So the range is 0 to infinity. Now the next one we're going to go over is the natural log function. It turns out that the natural log function is the inverse function of an exponential function. The exponential function had a horizontal asymptote at x equals 0. The natural log function has a vertical asymptote at x equals 0. I meant to say that the exponential function had a horizontal asymptote at y equals 0. Of this one, it's x equals 0. Because they're inverses of each other, everything is switched. The horizontal asymptote of the exponential function is now the vertical asymptote of the natural log function. Now this function is going to increase, but at a decreasing rate. Also, the domain of the exponential function is the range of the natural log function. And the range of the exponential function is the domain of the natural log function. Whenever you have two inverse functions, the domain of the original function is the range of the inverse. You can switch them. So as you can see, the lowest x value is 0, the highest is infinity. So therefore, the domain is 0 to infinity. Now looking at the range, the lowest y value is negative infinity and the highest is infinity. This graph will keep going up forever. It just goes up slowly. So it's negative infinity to infinity. Notice what happens when we put the two functions together. So here's the exponential function, e to the x. And here's the natural log function, ln x. Notice that it is symmetrical across the line y equals x. Each graph is a reflection across this line. And that is typical of inverse functions. An inverse function is, or will reflect across the line y equals x compared to its original function. So that's something you want to keep in mind.